Okay, so in this video, we will introduce a notion of alternating series. An alternating series is simply a series where the terms systematically alternate between positive and negative. So if the first term of the series is positive, then the next will be negative, then positive, then negative, and so on. If the first term of the series is negative, then the next will be positive, then negative, then positive, and so on. And here's how we can very easily construct an alternating series. So we can take a positive sequence, so assume that Bn is positive, 4, and we'll begin the sequence when n starts at 0, but we could begin at any other point. But suppose we have a positive sequence, then we can construct the corresponding alternating series summing from 0 to infinity, negative 1 to the n times Bn. This term will create the alternation, right? Whenever n is even, negative 1 to an even power is 1. Whenever n is odd, negative 1 to an odd power is negative 1. So if you write out the first few terms of this series, you will see that you have an alternating series. So when n is 0, negative 1 to the 0 is 1 times b0, which is positive, plus when n is 1, negative 1 to the 1 is negative 1 times b1, so minus b1, plus when n is 2, negative 1 squared is 1 times b2, so plus b2, and you see where this is going. Then n is 3, which is odd, so negative b3, then n is 4, which is even, positive b4, negative b5, and so on. And that's what an alternating series is. Positive, negative, positive, negative, positive, negative, forever. And it has to be a systematic alternation. You can't have, let's say, 2 positive, then 3 negatives, then 5 positive, then 7 negatives, and so forth. It has to be systematic. Positive, negative, positive, negative, forever. Or, if we start here summing at 1, then we would have negative, positive, negative, positive, negative, positive, forever. As long as there is an alternation in sign, we have an alternating series. So let's look at an example of this. So suppose I look at the sum from 1 to infinity, 1 over n. So if I expand this out, I have 1 plus 1/2 plus 1/3 plus 1/4 and so forth. This is clearly not alternating. We have a sum of strictly positive terms forever. So this series is not alternating. And we can say something more. This is the simple p-series where p equals 1, or the harmonic series. And we know that this series diverges. So as we keep adding more and more terms, the sum becomes larger and larger and larger, and then the limit grows out of bounds, so this series actually blows up. But what if we tweak the series just a little bit to make it become an alternating series? So what we'll do is we'll slightly tweak our sequence by squeezing on the numerator negative 1 to the n plus 1. Over n. Well, let's look at the first few terms. When n is 1, negative 1 squared is 1 over 1, so it's 1. Then we'll have when n is 2, 2 plus 1, 3, so negative 1 cubed is negative 1 over 2. Then when n is 3, negative 1 to the 4 is 1 over 3, so plus 1 over 3. And you see that the negative 1 to the n plus 1 will create the alternation. Minus 1/4, plus 1/5, minus 1/6, plus dot dot dot. So this series is clearly alternating. Positive, negative, positive, negative, positive, negative forever. So this is an alternating series. What's interesting is that if you remove the alternation, then the series blows up to positive infinity. As it turns out, this alternating series does converge, and not only does it converge, of course, by giving us a real number, we will show later on that this infinite series converges exactly to the ln of 2. And this is right now far from obvious, but we will show this later on. So if you wanted, say, to calculate ln of 2 by hand, you could start adding these terms up. 1 minus a half plus a third minus a quarter plus a fifth minus a sixth. And as you keep adding more and more of these terms, you will get a better and better approximation to ln of 2. So the question now is, okay, well, when we're given an alternating series, is there a simple test to determine when the series converges? And the answer is yes, and this is what we'll look at in our next video.